Hi, this is Dr. John Bergdorf. This video is a review of solving quadratic equations in one variable. So what I have in mind with this video is that at this point, what I hope you've done is you've had a series of lessons on how to solve quadratic equations. And in those lessons, they showed you probably four methods for solving quadratic equations, which we're going to mention briefly. And now that you've looked at that, the question comes to mind, well, how do I decide which method, and how do I just practice for a while so I can use this on a test or for other kinds of problems? So if you have not yet studied quadratic equations in detail, you might want to look at videos on those topics right now, because this is really designed as sort of a wrap-up. Now, when we talk about methods for solving quadratic equations in one variable, I guess it's a good idea, first of all, to talk about what we mean by a quadratic equation. Well, a quadratic equation is an equation that has an x squared term in it. The most general form of a quadratic equation happens to be mentioned right down in here. A quadratic equation in one variable can be written in the form ax squared plus bx plus c equals 0, where the a, b, and c are real numbers. And we also say that a is not equal to 0 because if it was, then that term would essentially go away and it would not really be quadratic. Now, here you do see two of the four methods for solving quadratic equations. One is the zero factor property, probably the most famous. This is the property that basically says in words that if you have the product of several factors and that product is equal to 0, then at least one of the factors must equal 0. So this is the method where you take a quadratic equation, rearrange the terms so a 0 is on one side, factor the other side, and then the zero factor property gives you the permission to set each factor equal to 0. So that's the zero factor property. That's one method. Another method is the quadratic formula. The solutions of an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0, are given by this very, very famous formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In fact, that is so famous that that's been made into a song. If you haven't heard the song yet, I'm going to sing it for you because although you will most likely find it incredibly annoying, it will stick with you and help you remember it. And here's how it goes. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can laugh, but if you get in the middle of your next test, I wouldn't be too surprised if you sing that song to yourself. Now, there are two other methods for solving quadratic equations that we're actually not going to mention in this video. One of them is mentioned elsewhere, and that's the method of completing the square. And I have a different video specifically for that one. And finally, the square root method, which frankly has somewhat limited application, so at the moment we're not going to really put a lot of effort into that. So looking at mainly these two methods for this video, which will, by the way, help you solve any quadratic equation that you see, the question becomes, how do you decide which one to choose? Well, the best way to do that, I think, is to try some examples. And actually, since this is a review, here's how I'd like to do this. I'm going to show you an example in just a minute. And what I'd like you to do is, before I do anything, pause the video, try it for yourself based on what you have learned, and then we'll come back together and work it together and see how it goes. Maybe as a little hint before we get too far into these, the zero factor property has a sort of implied necessity to it. You have to be able to factor the polynomial. So if you can't factor the polynomial, you can't use the zero factor property. Keep that in mind. All right. Now, here's our first example. Solve the equation x squared minus 4x plus 7 equals 0. Take a look at this. I'm going to ask you to stop the video right now and try it, and then come back and see how we do. Okay, we're back. So we do have the two methods that we talked about. One is the factoring method. And the reason I gave you that hint right before I set you to work on this is I think you'll see, whether you use trial and error or any other method, that you had a lot of trouble factoring this. It doesn't factor. It's a prime polynomial. If it doesn't factor, if your quadratic polynomial doesn't factor, the quadratic formula always works. All you have to identify is in this equation, what does the A represent, what does the B represent, what does the C represent. A is the coefficient of the x squared term. Here that's a 1. B is the coefficient of the x term. That's negative 4. And C is the constant term. That's a 7. So again, looking at the formula and remembering it, maybe we'll go back for a minute. This is what it looks like. We need to basically plug into that formula. Maybe I'll rewrite it again here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now plugging everything in, negative b is negative 4. So notice that there's a double negative there. Plus or minus the square root, or principal square root, better, of negative 4, that's your b, squared, minus 4, that's always a 4, times 1 times 7. All of that divided by 2a. Oh, silly me, we want to plug in the a. The a is 1. There. Let's simplify some more, see where this takes us. Negative 4, that's positive 4. Under the radical, negative 4 squared is 16. 4 times 1 times 7 is 28. Simplifying the radical a little bit farther, 4 plus or minus 16 minus 28 is negative 12. Now we do at this point know about complex numbers, and that radical can be simplified. We can factor it into a perfect square. Notice that the 12 is 4 times 3, times a negative 1, principal square root of negative 1, times principal square root of 3. So 4 times negative 1 times 3. The reason we would want to do that, I need a little bit more space over here. The reason we would want to do that is that tells me that the radical will simplify to 4, or the answer will simplify to 4 plus or minus 2. That's the principal square root of 4. Principal square root of negative 1 is an I, and then you have the principal square root of 3. Getting simpler all the time. You should always look and see whether there's anything in common between the terms of the numerator that you can factor out. Notice that there is this time. You can factor out a 2, and that would leave you with 2 plus or minus I times the principal square root of 3 divided by 2. So factor out the common factor of a 2 from the numerator. A really valuable thing here, because as you will see, the 2 in this numerator will divide the 2 in the denominator. 2 divided by 2 is 1. And the answer simplifies this far. These are unlike terms. They cannot be combined. But it is 2 solutions. So although I'm going to leave it with the plus or minus, the 2 solutions are 2 plus I, principal square root of 3, and 2 minus I, principal square root of 3. In the tradition of our class, we're going to write our solutions into a solution set, and so that will simply look like that. So that's a first example of solving a quadratic equation. We had to use the quadratic formula because the polynomial would not factor. Let's look at another one. So again, I want you to try this one on your own. I'm going to ask you to stop the video right now. Okay, hope that went well. So whether you use the zero factor theorem or whether you use completing the square, the quadratic formula, both of those methods require that one side of the equation equals 0. So before you can do anything, you're going to have to, first of all, subtract 11x from both sides and subtract 10 from both sides so that one side is 0. Now, in the previous example, the polynomial didn't factor. This time it does. So let's take a look at that just to be sure. Using traditional trial and error factoring, we know that if this trinomial factors, it will factor into two binomials. I'll leave the equal 0 over here. There has to be an x in one term of each binomial so that when you multiply it back out, you get the 6x squared. And the product of the coefficients of those two x terms has to equal 6. So that might be 2 and 3, it might be 6 and 1. We'll see which one we're happiest with. Similarly, I'll change colors for a minute. The constant terms, they would multiply together to give you the last term of the polynomial. They'd multiply together to give you a negative 10. So you need to look for two numbers that when you multiply them together, you get negative 10. Now, you may not make the, quote, right choice first. What you do is you choose something, and then you multiply it out to see if it happens to be right. So just in the interest of time, and hopefully as you played around with this, you found out that this worked. If I put a 3 here and a 2 here, that gives me a product of 6. And if I put a 2 here and a negative 5 here, that gives me a product of negative 10. Now, just because the numbers I'm putting in the blanks give me the right products does not mean this is the right factorization. You have to multiply it out. When you use the FOIL rule to multiply it out, if you like, the first term ought to turn out right because you specifically chose these two numbers to give you a product of the first terms, to give you the 6x squared. And the last term really ought to be all right too, because that is how you would get your last term of the polynomial, how you get the negative 10. So really all you have to check is not the full FOIL, but just the OI, or I say check the OI. The outer product here is 3x times negative 5. That's negative 15x. The inner product is 2 times 2x. That gives me 4x. And sure enough, that's negative 11x. Now, once you're good at this, you can skip a lot of the arrows and check marks and all that sort of thing, and hopefully just see, cleaning this all up, that this factors like this. Now, this is where the zero factor property comes in. Once that is factored, for the product of these two quantities to equal 0, the only way that can happen is if one or the other of these two quantities is 0. So this is why we say, let's set each factor we get equal to 0, and whatever values of x that I get from those factors would give me a solution. First one's pretty easy. It's a linear equation. You can subtract 2 from both sides and divide by 3. And in the second one, you can add 5 and divide by 2. And again, in the spirit of the way we are doing things, let's write our solutions as a solution set, negative 2/3 and 5/2. Now, quick observation. If the polynomial factors, the easiest thing for you to do will be to use the zero factor property, to factor the polynomial and set each factor equal to 0. As you can see, that fits fairly neatly in one column of the page. However, there may be, like there was in the first example, a polynomial that doesn't factor, or maybe on a test, you're kind of nervous, and even though the polynomial does factor, you just don't see how it goes. The good news is the quadratic formula works always, as in always, on any quadratic equation. So what I'd like to do is work this problem a second time in case you used the quadratic formula and show you what that would look like and kind of some pluses and minuses. So let me just clear out what I have written, and we're going to start over but using the quadratic formula. Now, you still have to get a 0 on one side, so you still have to say 6x squared minus 11x minus 10 equals 0, and then this would be your a in the formula, this would be the b including the negative sign, and this would be your c. Now, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, let's work on some numbers here. Hopefully you see where everything came from. So negative 11, that's positive 11. Negative 11 squared is 121. 4 times 6 is 24, times 10 would be 240. It's a negative times a negative, so that's positive 240. And all of this is over 2 times 6, which is 12. Now, you're beginning to maybe see the downside of the quadratic formula. You might be thinking, I think I'll just always use this. Notice these numbers are getting a little on the big side. So you have the principal square root of 361. Now, it just so happens that 361 is a perfect square, and the principal square root of 361 is 19. And perhaps you might need a calculator to help you with that a little bit. Now, this represents two solutions. There's one with the plus sign and one with the minus sign. When the radical goes away, when you're solving the equation, like it does here, it is often best to just focus on the two separate answers you've gotten, one with the plus sign and one with the minus sign, and simplify those two results a little bit more. You should get some nice answers. So, oh, and look, that's supposed to be a 12. I miscopied. 12, 12. Okay. 11 plus 19 is 30. So this is 30 over 12. And 11 minus 19 is negative 8 over 12. All fractions should be reduced. So if you look at the first fraction, the 30 is 6 times 5, and the 12 is 6 times 2, so that the 6's divide out and give you 5 halves. And in the second small equation, 8, there's a common factor of a 4 here. 8 is 4 times 2, 12 is 4 times 3. The 4's divide out, the minus sign remains, and you get negative 2/3. Again, as a solution set, we would say 5 halves and negative 2/3. And if you don't trust me, you can back up the video, but it turns out these are indeed the same answers we got by factoring. I think you'll see that factoring is a lot quicker than the quadratic formula, but the quadratic formula is your friend. If you can't see how to factor something, just pull out Mr. Quadratic Formula and you'll be fine. Okay, that's two nice examples. Let's look at a third one. All right, so again, I'm going to ask you to stop the video, see what you can do, and we'll come back and work it together. So stop the video now. And we're back. So at first glance, this may seem a little bit odd because there's only two terms. There's a couple of things you cannot do. You cannot just divide both sides by x and divide out an x to get 2x equal 5, or x equal 5 halves. It's very subtle, but when you divide both sides of an equation by a variable, you are potentially losing a solution. You'll actually find out that 5 halves is a solution, but there's something else missing. So, whatever you do, don't do that. All right. Instead, let's get a 0 on one side. So I'm going to subtract 5x from both sides. Now, if we follow what we have about the factoring, the zero factor property, it will help here. This can be factored. But before you try all kinds of trial and error and AC method and all kinds of things like that, don't forget that the first thing you should look for is whether you can simply factor out a common factor, because that's what you can do here. You can factor out an x. It leaves you with 2x minus 5. And x is one of those factors that you set equal to 0, so that will give you one of your solutions. In fact, that solution simply is 0. And then the other one, you add 5 and divide by 2. So the solutions are 0 and 5 halves. All right, are you up to one more? Let's do one more. This one is not actually a quadratic equation at all. Quadratic implies the highest exponent is 2. This one is a 3. My hint to you is think about getting a 0 on one side and think about factoring, because that's the method that will help you. So I'm going to ask you to stop the video right now. All right, how did that go? A little bit more stuff in it, but let's see what happens. So no matter what, even though this is not a quadratic equation, we still, if we're going to use the zero factor property, have to have a 0 on one side. So let's take our equation and subtract 9x and subtract 9. There are 4 terms here. The only way to factor a polynomial with 4 terms is by grouping. So I'll have to group the first 2 terms and ask myself, what can I factor out of just that group? Notice there's a common factor of an x squared. And if you factor that out, you get x plus 1. In the second group, there is a common factor of a negative 9. Go ahead and make it negative so that we have a subtraction between 2 terms coming up. So, factoring out a negative 9, it would be multiplied by x plus 1. So miraculous. In grouping, if you do not get a common binomial factor, then you're really kind of stuck, at least for now. But since that worked, let's factor out that common factor of an x plus 1. And what we would be left with is an x squared from the first term and a 9 from the second. And remember sort of the unwritten rule of factoring, that you never stop factoring until you're sure that everything is prime. If you notice right in here, x squared minus 9 is a difference of squares. So I can factor this farther. Let's leave the x plus 1 alone, but factor x squared minus 9 is x plus 3, x minus 3. And then you set each factor equal to 0, even if there's more than 2 factors. Quadratic equations will have 2 factors. You can have more. No matter what, set every factor equal to 0. X plus 1 equals 0. X plus 3 equals 0. X minus 3 equals 0. Solve each one of those miniature linear equations, and you would get negative 1, negative 3, positive 3. So as the solution sets, what you would have would be negative 1, negative 3, positive 3. So those were some examples I chose to kind of show you different aspects of these 2 factoring methods. as you look at the homework that's been set aside for this chapter, feel free to come back and watch this video again, but try these same techniques. And I wish you all the best.